What up, mathletes? Whoop, whoop. All right. So we've got our warm-up right here. I want you to go ahead, take a minute, and fill it out. Pause me, because I'm going to get going here in about 3 seconds. Well, maybe longer. I'm going to take a drink real quick. So you guys should be working this through. You're just comparing. Is one side greater than, less than, or equal to the other side? All right, here we go. Unpause, hopefully. What does it say right here? Negative 6.23. So I need to put this as a fraction. So I'm going to make it, or as a decimal, negative 6.50. I'm going to make it match the amount of decimal points. Well, this is less negative. 6.23 is less negative than negative 6.5. So I'm going to say negative 6.23 is greater than negative 6.5 because it's less negative. Square root of 81 is 9, so this is negative 9, and then negative 9.3. Again, negative 9 is less negative, so it's going to be greater than negative 9.3. Use a calculator. When I divide this out, it's going to be approximately, what is it? I'm actually going to take this to 2 decimal places, otherwise it's a little bit deceiving because it'll round to 1.2. But really you should take it out to 2 decimal places because it's approximately 1.17. And this would be 1.20, right? So 1.17 is less than 1.20. And then right here, again, as a decimal, this is 3.5. The square root of 15 is approximately 3.9. 3.5 is less than 3.9. Okay? All right, let's go look at vocab. Again, as I always do, I'm going to display it for you, but you're going to need to pause it because I'm not leaving it on the screen for more than a few seconds. So go ahead and pause this. Make sure you have them all written down. I know they're a little confusing sounding. We will clear that up. But pause me, write it down. Okay, I'm assuming you paused it. Let's move on. We're going to go back to my notes because I've added a little something extra. So we're going to get into this. You're going to be filling in the powers of 1/2, nth roots, rational exponents, all that good stuff. But before you do, I'd actually like for you to write this next to the powers of 1/2. This is giving you a little bit of a better understanding of what an index is. An index tells us what kind of a root we're taking, right? The 5th root means I'm finding out what number times itself 5 times will equal 18. So in the case of 18, let's see, let's take the 5th root of 18. If you want to use a calculator to do it, here's how you do it. You have this nice little button that has kind of the x root right there. So I'm going to put 5, and then I'm going to use that. See that x root? So I want to take the 5th root of 18, and it's, you see that number, 1.7826, blah, blah, blah. If I round that, let's say 1.78. So if we did it right, 1.78 to the 5th power should be approximately. Okay, so let's try this out. I'm going to have 1.78 up to the 5th power. Look at that, 17.86, so about 17.9, which is right there up to 18. So that's what a 5th root is. So this right here is the index. Tells us what root we're taking. Then we have the radical symbol, which is the square root sign. And then underneath, the number we're taking the root of is called the radicand. So that's 3 of your vocab right there. All right, or 2 of them anyway. I think so, yeah. All right, and underneath that, I just have a couple examples I want to go through. So 3 squared is 9, but so is negative 3, as long as the negative in 3 is in parentheses, squared is 9 as well. So what does that tell us? Both 3 and negative 3 are square roots of 9. Same thing, if I have 2 to the 4th or negative 2 to the 4th, they both equal 16, which means 2 and negative 2 are both 4th roots of 16 because they were to the 4th power, right? Okay, write that down, pause as you need, we're moving on. We're going to fill out, so the next little bit, guys, I'm going to walk you through all 3 of these. Now, in some of them, I'm going to tell you, I wrote symbols and you didn't need it in like most of these, but just cross out symbols, use the spaces needed, it's not a big deal. So let's go back here. And the first one, again, you don't need symbols. It says for any non-negative real number b, b to the 1/2 means the square root of b. So when we write something to the 1/2 power, that's the square root. So m to the 1/2 is the square root of m. 64 to the 1/2 power is the square root of 64, which is 8, because 8 times 8 is 64. So again, pause this, write it down. I'm moving on down. Here's what we already wrote down. We're going to talk about nth roots for any real numbers a and b and positive integer n. If a to the n equals b, then a is the nth root of b. In other words, if a to the n equals b, then a equals the nth root of b. See what we're doing there? So because 3 to the 4th equals 81, 3 is the 4th root of 81, and the way we would say that is the 4th root of 81 equals 3, which is true. 3 times 3 times 3 times 3 is 81. All right, again, pause this. We're moving. By the way, don't stress too much. We're going to go through some examples which will help clarify what these are really telling us. And our last one, again, we don't need that symbols, but it says for any non-negative real number b and any positive integer n, b to the 1 over n equals the nth root of b. So in other words, if I had 32 to the 1/5, that's really the 5th root of 32. And since 32 is 2 times 2 times 2 times 2 times 2, 5 2s, that means it equals 2. Okay, moving on up to our last one. We're going to go to the back page. And let's go back to write our examples here. Now we're going to kind of put these powers from the first page, right? Those ones we just wrote down. We're going to put those into practice. So it says rewrite 2y to the 1/2 in radical form. Well, anything to the 1/2 power, we're just taking the square root of. So we're taking the square root of everything in the parentheses, which is 2y. Now let's go backwards. We're going to put everything under the radical sign. We're going to put the radicand into, right? This is the radicand. We're going to put that into parentheses, 20z to the 1/2 power because it's a square root. Just going backwards. Now let's evaluate the nth root. What does the nth root tell us? Well, it says the 4th root of 256. So I want to find what number times itself. 4 times is 256. Well, it turns out 256 breaks down into the 4th root of 4 times 4 times 4 times 4. 4 times itself 4 times is 256. So that means the 4th root is 4. In the same way, this wants to take the 7th root of 128. Well, it turns out 128 breaks down into 2 times 2 times 2 times 2 times 2 times 2 times 2. That's 2 times itself 7 times. And the 7th root of that, I've got to put my 7 right there, is equal to 2. Now, how would I really do this on a calculator? Let me remind me, if you have a calculator like this, I would write 7 for the 7th root, and I have the x root sign of 128. And what does it get me? Boom, 2. Now, our last one, what was that called? The rational exponents, tells us that this is my index number, right? That's just my index. Okay, so that means this equals the 4th root of 625. Well, what's the 4th root of 625? It turns out it's just 5. And last but not least right here, oh, I probably should have put 6, but I didn't. We're going to use some laws from a couple lessons ago, or maybe a lesson ago. But I'm going to, this is, again, my index. So since it's the 1/3, that means we're going to take the 3rd root of everything in parentheses. So the radicand is 1/27. But my laws tell me I can split this 3rd root up. So this equals the 3rd root, or a cube root, of 1 all over a cube root of 27. Now, what times itself 3 times is 1? That's 1. 1 times 1 times 1 times 1 is 1. What number times itself 3 times is 27? Well, that's 3, because 3 times 3 times 3 is 27. So this would be 1/3. But that was a terrible 3. It should be 1/3. Awesome. Some good examples there. And last but not least, we have our powers of nth roots, which I don't think needs symbols either, although there's an argument to be made for it. Excuse me. Yeah, I would honestly just put this whole thing in symbols. But for any real number b and any integers m and n is greater than 1, b to the m over n is equal to the nth root of b to the m power or the nth root of b to the m. So these two are the same thing written in different forms. And each one has its benefit depending on what you're trying to simplify. Again, take a minute, write that down. Ready, set, pause me. All right, we are going back to finish up this lesson. So on yours, it will be filled in. Mine is not. I've already done that on another sheet of paper. Before we do anything, let's look at these. Can we simplify that? Yeah, what's 15 divided by 5? It's 3, so this is really 4 to the third, which is just 4 times 4 times 4, or 64. How about 6 to the 7 over 7? That's really just 6 to the 1, which is 6. Those are simple, right? Things you can do. Now we're talking. So I can write this in two different ways. Let me split this down the middle. I can either write this as, right, this is my index, so the 4th root of 16 to the 7th power, 16 to the 7th power. Well, you can't really see that, can you? Or I can write it as the 4th root of 16 and all of that raised to the 7th power. Depends on which is going to be easiest. If I do it this way, I'm going to do the 7th power, get a humongous number, take the 4th root, and it's going to equal 128. But you'd only know that through a calculator. If I do it this way first, what number times itself 4 times 16? Well, that's 2. 2 times 2 is 4, times 2 is 8, times 2, that's 4, yeah, times 2 is 16. So I end up with, all right, now I have 2 to the 7th power. Well, if you remember from up top here, the 7th root of 128 is 2, so that means 2 to the 7th power is 128. See how this way was a little bit, this way it required us to do a huge number and then 4th root it. Trust me, it's humongous. Whereas this one, we could simplify it almost in our head. All right, this last one right here, we can either rewrite this as, once you take a minute, pause me, see if you can rewrite this in both methods. Okay? This is either the square root, right, because it's a 2 on bottom, so we just leave the square root of 5 to the 3rd power, or it is the square root of 5 in parentheses, all raised to the 3rd power. I'm going to do it this way because this isn't a perfect square, right? So I'm going to go ahead and multiply this out. 5 times 5 times 5 is 125, so this just equals the square root of 125. We can estimate it, round it to whatever if we need to, but I'm not asking you to this time. Boom. All right, that's today's lesson. Get ready, set, go. Peace out.